let me welcome up on stage Dr. Conor MacCormac.
Thank you. Good afternoon, everybody. So today I'm going to talk to you a little bit about 3D printing. I'm going to explain how 3D printing actually works. Some of you probably know about it already, but for some who haven't, I'll just talk about the whole concept and why 3D printing has got such a big deal. Oh, wait. No? Yeah. Then I'll talk about how 3D printing is used currently, and then I'll finish up talking about 3D printing and how it could potentially be used for the future. I think some of the talks we had earlier have been very, very interesting. One or two have kind of touched on some of my future slides, and I was hoping that somebody didn't steal my thunder. But I'll hope today that I'll give you kind of a sense of what 3D printing can be and how exciting it really is. So what is 3D printing? So at a very, very top level, very basic level, 3D printing is all about taking the digital data, a file that you have on your computer, and bringing that from the digital world into the physical world. So that's at the very basic level, and that's really what it means. So the first thing that you need to do is that you need to be able to generate the 3D data. So you need to get that information onto your computer. There's a lot of different ways of doing that, and it's changing literally on a day-by-day basis. So you can use things like a scanner, very similar to a scanner that you have in your Tesco's when you're scanning out your barcode, but yet this scans in 3D. You use computer-aided design. Architects and engineers design all the time, your 3D objects. You can use the World Wide Web to download designs and maybe customize that design a little bit to make it out to what you want to really customize a part. Or ever increasingly, you can use mobile devices. You can use your iPhone, you can use any type of phone you have, and you can actually take pictures and take scans of your object. So once you have your 3D data, you send it to a piece of software, which then sends it to a 3D printer. As you heard earlier, there are many other different types of 3D printers. We have invented one of these types of 3D printers, and you can see it on the first floor when we leave here. And the way I want you to think about a 3D printer is like tools in a toolbox. You wouldn't use a hammer for where you need a screwdriver. Different 3D printers have different niche and different applications, and everyone has a kind of its own strength. But then from the output from that digital data, you actually print out your physical objects. So you take that digital design and you actually print that out. And believe it or not, the first 3D printed part is almost 30 years old. So this year, the first 3D printed part 30 years ago was printed. And that might be surprising to a lot of people here because there's been a lot of attention about 3D printing lately, and people talk about 3D printing like, oh wow, it's just arrived, but it's actually been here a very long time. So in terms of air technology, a little bit about air technology, what's our unique selling point? Well, our selling point of an air technology is that an air printer runs simply on regular paper. So we take 3 reams of standard office paper that you get in your Office Depot, in your storeroom at work, and you combine it with a 3D printer to produce tough and durable and full color 3D printed parts. And I promise I wouldn't do a sales pitch, but that's basically how our technology varies from everybody else's. But because it's paper, it's extremely low cost. You're talking maybe 7 to 30 times cheaper than the next competitor. It's very, very green. You can throw the whole thing into a paper recycle bin. And as you can see with the color, we can use ink and paper to produce very realistic parts. Here are some examples of 3D printed objects from our machine. This is made up of photographs actually from an archaeological dig of a skull. And you can imagine rather than having the actual artifact, you could 3D print that and have that all around the world and show them in a lot more locations. And believe it or not, this is also one of our 3D printed objects. So what's the big deal? As I said, it's been around 30 years. Yet people are only talking about 3D printing now like it just happened. And there's a lot of different ways that you can look at 3D printing and talk about the power of 3D printing. But I just wanted to kind of bring it up to the first principles and try and kind of say, what is the big thing about it? What's so unique? And to do that, I just want to show 2 objects. So this on the left is more of a complex object, and on the right is a simple, it's supposed to be a cube or something, but a simple kind of an object. Now with conventional machining methods, and by that I mean you start off with a block of material and you machine around the outside, a block of metal, a block of wood. With conventional machining methods, the object on the right would be a lot cheaper to make than the object on the left. It's just a simple shape, a couple of passes on a mill machine and it's made. This would be a lot more complicated and a lot more expensive. So the way manufacturing has been since it started, the more complex the object it is, the more expensive it is. But the very interesting thing about 3D printing is that that is all changed. So if each of these materials is the same volume, so if that block on the right was 100 cubic centimeters and this little model engine was 100 cubic centimeters, in 3D printing, effectively, they're the same price to make. When you think about that for a second, that completely breaks down the whole manufacturing model that people would be familiar with. So it doesn't matter how complex the object is. Really, if it's down to the same volume, it's going to be the same price. And what that means is that complexity is free. And there's a lot of other advantages of 3D printing, but that's kind of, I would feel, the top level, that the complexity is free. So kids now can design objects. They don't have to worry about how complex it is and hit print, and it'll print out the object. It's a very, very big shift, big change. So what has 3D printing been used for? I'm not going to go into this pie chart, but effectively, up to the last 2 years, so 28 years, it's primarily been in the commercial sector. So you'd have architects, engineers, MCAD, mechanical engineering design, and the people use it for prototyping, they use it for sand castings, they use it for form and fit, they use it for some direct part production. But really, it's changed a lot over the last couple of years to consumer. So there's been a real explosion in the consumer level of 3D printers where people can now buy kit machines or fully assembled machines for a couple of thousand or even under that. And it seems to be a new Kickstarter project every day. The starting of a new type of a 3D printer out there. So it's really, really changing a lot. Some examples, industrial design from mobile phones to parts of bicycles, frames, architecture, printing out houses, printing out what way the sun is going to pass around your new building. Looking at geographical information systems, you can imagine taking the town plan or taking the surface of the seabed for companies laying pipelines. There's so many applications where you could use this idea. Footwear industry is very interesting. Casting, so taking sand casts and taking metal casts of your 3D printed parts. The packaging industry, models here on the left that you'd print out overnight, you would show exactly what your bottle is going to look like. Or on the right-hand side, you can have a living hinge, so you can actually fold objects over straight from a 3D printed object. The whole medical dental area, and you've heard about that already in some of the talks this morning, that is a real explosive area, and one of my future slides is a little bit more about the whole medical side. But at the moment, it would be primarily used for surgical aids on the left, the area of orthodontics on the top right, hip replacements, printing out the part of the hip and seeing that the actual socket fits into it prior to doing the surgery. Education. So education is a big thing for 3D printing because obviously, you hear people saying this loads of times, it's the young people that are going to be the engineers and the innovators and the designers of the future. And in all those verticals that I've shown you before, architecture, all those things, obviously education is a big area for 3D printing. This is something I think is very interesting. Google has changed the way it generates the maps, so it actually generates real 3D objects now. So they're trying to fly over the world and generate 3D data from where they used to before was just like a photograph image of Google Earth. That's a big push for 3D printing in the future. There's an interesting idea from an ultrasound. So you can imagine taking an ultrasound scan and taking that scan data and actually generating 3D models from that and printing that out. You can imagine the applications of that. The whole area of art is very interested in the area of 3D printing. And finishing off here on examples here with the entertainment consumer segment. So it's not enough now to go through a thrill-seeker ride and get a photograph you take and being splashed with water or something like that. Now you can get, in some of these theme parks, you can get a scan taken of your face and get your face superimposed onto a stormtrooper. I'm sure there's a few people here that would like that. Or on the right-hand side here, a wedding photograph. So taking, which we heard in the previous talk, I know it's completely different, but kind of, if you could take an old photograph of somebody now that's grown up and maybe somebody that's passed away and take that photograph and make that into 3D. Like we've had examples where grandparents would say, when I go to bed, I touch the head of my grandkids from a photograph because we can print that out in 3D. So that's kind of blending, bringing the whole history kind of into reality to being able to touch it. So that's examples. I hope I give you a flavor of what it can be used for. So on the second slide, I talked about, you need to start off with the data. And that's a big challenge for the future of how 3D printing is going to grow. The technology has changed a lot, but the whole ecosystem needs to grow also. So you need to be able to generate the data easier and easier. I know people have a hard time programming their TV, yet alone run a 3D printer home in the house. Yet it needs to be that easy. It needs to be like you hit print and it comes out. And that's where we need to go for this thing. So I'm just going to talk about one kind of area of data generation. And if you were at a 3D printer show, even like 3 years ago, the idea of scanning, I showed a slide earlier with a barcode scanner. If you wanted to scan an object in 3D about 3 or 4 years ago, it would have cost you around 45,000 sterling for the scanner. And these scanners were used in industry for scanning parts of cars and reverse engineering components. But now that the whole price point of scanning has come way down, which means that people, you don't have to be a designer now. You can actually scan any object that you want. Here's an example. You might be familiar with that scanner. It's from a Kinect scanner. We have one sitting on top of the printer on the floor here. I think it was £20 in the second-hand store. And then you can use free software, or you can pay for the software. I think it's £100 to get the professional version of the software. That enables you to scan objects in 3D. So you can scan a person there and print that person out. And you think how much that has changed over the last couple of years. The whole idea of photogrammetry is effectively the process of being able to take multiple objects of something, sending it to the cloud, and really clever software stitches those photographs together to generate a 3D file. So if anybody here has an iPhone, you can go online now, maybe not now, and you can download an app called 123D Catch, which is made by Autodesk, and that'll enable you to go around an object, and you send it up to the cloud, and it'll send it back 5-10 minutes later, the actual 3D data of that object. And there's a lot of new areas around this photogrammetry. You could do a thing like you see in how they did the Matrix movie, with a series of cameras that kind of capture the people moving and doing all that kind of stuff. Well, there's an idea of a photogrammetry where you can walk into a kind of an array of cameras, SLR cameras, and it'll take a snapshot in time in 3D, very rapid burst, and you get very, very high detailed 3D data of people. Yet that's very expensive. You know, you have a lot of these cameras and you have to link them all together. And I just want to talk about some of the kind of future stuff a little bit here. There's work that's going on in Glasgow, and it's called a single pixel camera. And people in the industry believe that this is going to be a big game changer. And it's kind of counterintuitive to think that a single pixel camera will be better than an SLR camera at 40 megapixels. But effectively, what this is single pixel cameras that are only a couple of pounds each. A computer projects an image onto the object, a computer controlled image, and the single pixel cameras take a 2D snapshot of that object and they piece it all together. So it's a very low cost future, but what's even more interesting is that it'll work in the X-ray and also in the terahertz range. So you might be in the future be able to take a photograph of it inside your body or inside an object or inside a machine, take a photograph in 3D and get that printed out. So that's a little bit about what it's been used for up to now. And because we are talking about 2045, I'm going to just talk a little bit about what it could potentially be used for in the future. Sorry. So that video wasn't supposed to start straight away, but effectively, the first thing I'm going to talk about is fully functional models. At the moment, most 3D printers out there either print out plastic, they print out something that's like metal, they could print out stuff like sand, like sandstone. Air machine obviously runs on paper, and each one has its own strengths and weaknesses. But I think in the future, like 10, 20 years from now, we are going to have materials that are exactly like the materials that you have in your car. So you'll print out a carburetor, you'll print out an engine block, you'll print out a crankshaft, you'll print out part of your mobile phones, and this is functional parts straight. You'll bypass the whole tooling stage. You'll go straight from data, straight to an object, and they'll be fast enough to actually be in a production run. It won't be like a prototype. And what I'm going to show you next, that really loud noise, is an example of what's been done now in the leading edge of kind of material research. And this is an image provided by NASA of a fuel injector in a rocket engine. And that fuel injector before used to be made up of 115 components. And then they 3D printed this rocket engine injector. It's only 2 components now, and it can withstand the very violent forces that you would see in a rocket engine. It's a very short clip, but I hope it's not too noisy. So people have a misconception that maybe 3D printing parts are delicate, but as you can see there, they're not, and that's going to be the future. 3D printing on other planets might sound a bit wild, but a couple of years ago we were contacted by the European Space Agency, and some of you might have been involved in some of the universities, to come up with an idea for a 3D printer to print on the moon. And as much as we would have loved to have done it, and we came up with an idea, we're so busy trying to build our own printer here on Earth that we decided we just couldn't get involved. But Fossils and Partners in London have designed what a habitat would look like on the surface of the moon. So on the left, you can see what Fossils and Partners designed, and on the right-hand side, you can see a 3D printed part here that was built here on Earth that was made up of material that was a simulant of what the surface of the moon is like. And that part on the right is actually 1.5 ton in weight. It was like a gantry that was built up that would go over the powder of the moon and actually build up your object. So the idea would be that you'd send a probe onto the surface of the moon 6 months or a year before you need to send up any humans, and it would just go off automatically and build a habitat. And then when the humans land there, they're completely shielded by this thing that's a couple of meters wide, completely shielded from all the radiation that you might get from the sun and all that. So that's pretty wild, but we're already doing stuff like that kind of already at the moment. So what we see here is a bit of an exclusive here. On the left-hand side is a scan taken from the orbiter that's going around Mars. And on the right-hand side is an actual scan taken from one of the rovers on the surface of Mars that drove around one of the objects, and they just call it the rock. And then they sent that data back from that rover, and we printed that part out. So do you think an idea, people printing on different planets are taking data from another world and bringing it back here and printing it on Earth? It wouldn't be the same material, but it'd be the exact same shape. It's very interesting. People are already starting to experiment with printing in space. So NASA are just about to launch a 3D printer to go into space. And what's really interesting, two areas about this, is that in the future, for long missions into space, you won't have to bring so many spare parts. You just need to have the 3D printer and the raw material. And if something breaks down, you just print that whatever broken part on the spaceship. But what they're really looking at as well is the idea of being able to print food. And it's not a case of just mixing in, flour and milk and a few eggs, and it would just, a food mixer or a blender could do that now. This is more like synthetically building, almost like meat, building all the kind of food that you would need. And that's what NASA is kind of exploring, the whole idea. So bioprinting. The whole idea of bioprinting, I think, is very exciting, and in terms of the future, I think this is huge. As one of the previous speakers talked about the whole idea, this is an example of what's actually been done. This is a lady that had to have her lower jaw replaced due to, I think it was cancer, I'm not sure. And this is a 3D printed part. The whole lower jaw was 3D printed and then inserted into the lady's face. And that's really, really interesting. And the whole idea of integrating, 3D printed objects with the body, as we heard even from the very first speaker, this whole idea of being integrated is very interesting. We see in a previous slide of a kidney being printed, the whole early start of 3D printing kidneys. Here we have an example of an ear that was printed. And what's interesting about this is not only that it's printed out like in cells, but there's an embedded electronics. So the whole idea of bioparts with embedded electronics, so the printers can do both biomaterial and electronics. You can imagine where that might lead. And there's a lot of work that's gone on about printing bones. So you can imagine you have a very bad accident, and instead of just breaking part of your arm, you actually smash the lower part of it, and it needs to be replaced, usually to take something from your hip or try and fasten something from part of your body. Well, you can imagine going into the doctor and actually getting that part of your bone 3D printed, to insert that into your body, and then your bone grows through that 3D printed structure to give you a bone that's as strong as it was before, or I think very interestingly even could be stronger than what it was before. You could have enhanced properties from that, and who knows where that might lead. So what I'm going to finish off with is the idea of what would happen if you combined the idea of 3D printing in space with the whole idea of a fully functional bioprinter that could print, organisms to even something a bit bigger, like a whole living structure. With the whole idea of the DNA structure, the blueprint of life, Can you imagine a situation where you send a probe, like the ones that are on Mars, you send a probe out to another planet, and on that planet, as we heard earlier, the DNA sequencing went from 100 million down now to 1,000, I think it was on that graph. And in the next 10 years, it's going to be in the pounds and it's going to be in the pence to be able to break down your DNA sequence. So you could imagine one of these devices on another faraway planet, and it's checking out for life, alien life. And if it finds it, it'll break down the DNA structure, and it'll send that information back to Earth at the speed of light via electromagnetic waves, and it'll be printed, the living alien life here on Earth. It's a pretty wild idea. And this isn't my idea. I can't take credit for this, unfortunately. The guy called John Craig Ventnor, who was one of the guys who helped to map the human genome in 2003. And it's one of his ideas of potentially this could happen in the future. But what I want to leave with here is this idea. The volume will come down in a minute. So here we are on the Earth, spinning around our axis, going around the sun in our solar system. Could you imagine if the human blueprint or the DNA of life was sent out from the Earth and is leaving the Earth at the speed of light? And it's traveling out through our solar system. And what would happen in the future if there is such thing as an alien life form? If an alien life form got this data, effectively what they would be able to do would be to print a human on their planet. And believe it or not, that might have already started, because in 2003, when the human genome was mapped, that data was sent out around the world, it was broadcast, and it's been leaving the Earth at the speed of light for the last 10 years. So that data has now traveled 10 light years from Earth. So this whole idea is pretty interesting. And this could be, and we even know who the first person it is they're going to print because it's John Ventnor, because it was his DNA sequence that was first mapped. So there'll be loads of John Ventnors all over the place on different planets. But I just want to leave you with the idea that this could be the ultimate in space exploration. So effectively what you have to do in the future is just simply email yourself to another planet. So thank you.
Thank you, Conor. Now, a lot of people, when they talk about 3D printing, they seem to talk about something that you've not mentioned today, which I kind of like. I think there's a lot of realism in it. Is the idea of having our own 3D printers at home.
Yeah.
And it's a lot of the Kickstarter projects are about that, about trying to create sort of small little portable printers, that even rip-wrap ones that you can reprint yourself and give to other people. Mm-hmm. What do you think of that whole idea of domestic printers? Because to me, when there was normal printers, everyone who needed a normal printer had one very early on. But 3D printers, they haven't been adopted domestically.
Yeah, it has accelerated the adoption of the technology. So people talk about democratization of innovation. And if you really look at how big companies innovate, if you look at some of their products that they have and you'd ask them, who innovated this, who came up with this idea, they will say, well, we did. But a lot of examples when you look at it's actually people, it's us, people out on the street who have a problem with a product, and we modify it a little bit, and then you have a little community and people say, I really like this, and you get a kind of a following, and then the company will say, oh, that's a really good idea, I didn't know our product could be used for that, or they say, oh, I knew it could be used for that, and then they will incorporate that into their own products. And I think what 3D printers like that, the kit machines and the entry-level machines and the machines at home, it'll enable people to innovate, it'll enable students to innovate faster. And in 5-10 years' time, you'll pick up a device and you say, oh, this is perfect. This is just what I wanted. I always wanted a device that would do this or fit in there. And it'll feel like it's completely customizable to yourself, because it will be. It'll be kind of a customizable object. So I think it's brilliant. I mean, I remember when we first started this idea, we came up with the concept 10 years ago of building this 3D printer. And when I used to talk to people about 3D printing, they would say, do I need 3D glasses to see the object? I'm like, no, this is a 3D printer. To now to extent where people on the street come up to me and say, oh yeah, I know what a 3D printer is. And just, we heard it last week, you can get your prints done in ASDA. You can go in there and get a scan done in ASDA and get yourself printed out. And there's a lot of kind of big, we've done a deal with Staples where you can upload your content and get the same thing to Staples. So I think it's going to be, it's all good. It's scraping the surface. The industry is so small, but the potential is really to cause another industrial revolution. It could really change how things are made in the future because complexity is free.
That's wonderful. Conor, thank you very much indeed.
Thank you.
Thank you.